Okay, today is January. Let's add a new page here. Today is January 19th, 2012. We're going to go over your Chapter 1 test. Okay. So the first question we're going to deal with is question number 8. It says for questions 8 and 9, a full solution is required. Identify the variables. So let x, let y equal something. State the equations, and then solve. Include let statements in a concluding sentence and a concluding sentence. It may be helpful to use a table if you need to. Okay? So, first question says, Mr. Milne needs to make 10 liters of a 42% sulfuric acid solution for a lab he is doing with the students. In the supply room, he finds a bottle of 30% sulfuric acid solution and 60% sulfuric acid solution. What volume of each solution should he mix in order to make 42% sulfuric acid? So I need to make let statements. So what I'm going to do to start off is let x equal amount of 30% solution. Sure I do. And we're going to say let y equal amount of 60% solution. Okay? It's closer just because I didn't want to rewrite it again. So I have my two variables. How much solution does Mr. Milne need to get? What's the total amount? 10 liters. So that means, essentially, we'll call x the red one, y will be blue. If we were to add up all of the amount of x plus the entire amount of y, how much of the solution would we have? 10 liters. So this is one equation right here. X plus y is equal to 10. Okay? Now the second solution, we need to figure out how much sulfuric acid there's going to be. Okay? So what this means is in the very first question, he said he needed 42% sulfuric acid solution. So 42% of that 10 liters needs to be sulfuric acid. So what I'm going to do here is I'm going to multiply that 10 liters times 0.42. This is going to tell me how much sulfuric acid is in the solution. Okay? So I multiply the 10 by 0.42. Our x is what percent solution?
0.3.
0.3. So I'm going to multiply x by 0.3, and that'll tell me how much sulfuric acid is in that amount, in that solution. And the other was 0.6 times y, because it's 60% sulfuric acid. Okay? So my two equations are here. X plus y equals 10, and 0.3x plus 0.6y is equal to 4.2, is what that's going to be. Right, so 0.3x plus 0.6y. So these are our two solutions. Okay? What I'm going to do is I'm going to make some room on the next page, and we're going to take this up. Now, we've learned 3 different ways in this chapter to solve this. First method, which would probably be the most difficult for this style, is what? Anyone remember? Graphing, that's right. By graphing these two lines. So this is going to be relatively difficult to graph. What's another way we could solve this? That's right, substitution. And third one? Elimination. Okay. What I'm going to do for this one, because I think it'll be straightforward, is we're going to use substitution to solve this question. Okay? So we're going to use the second one. Now, in order to do substitution, what do I need to do to one of the equations? Yeah, that's right. I need to set one of them equal to y or x. Looking at these two, which one do you think is going to be easier to set equal to one of the variables, Nick? Yeah, the first one will be the easiest to set equal to. So I'm going to take the first one, x plus y is equal to 10. Let's set it equal to x. So when I move y to the other side, x equals 10 minus y. Very simple. So now what I do is I'm going to put the second equation down here. And this time for x, we're going to replace x with what it was equal to in the first equation. So this x here is going to be replaced with that value, okay? 10 minus y. So now we'll get 0.3 multiplied by 10, subtract y, plus 0.6y is equal to 4.2. Okay? Now, I need to use distributive property. I have to distribute this value. So 0.3 times 10, anyone know? 3, good. 0.3 times negative y? Negative 0.3y plus 0.6y is equal to 4.2. We're going to collect our like terms, okay? My coefficients with a variable attached, my y's are like terms, and the 3 and the 4.2 are like terms. They're constant numbers. So I'm going to move the 3 to the other side. So I have negative 0.3y plus 0.6y is equal to 4.2. When I move the 3 over, it becomes, right? So I have them on their respective sides. Negative 0.3 plus 0.6y is?
0.3y.
Yeah, positive 0.3y. 4.2 minus 3? 1.2. Okay. Now, to isolate y, what do I need to do? Divide each side by 0.3. Y is equal to, anyone know? 4. So we've solved for y. If we were graphing it, and we were to write a coordinate out here, our y coordinate would be 4. So we have that amount. To finish off substitution, what do I need to do after? I need to solve for x. So I need to plug this 4 value back into, does it matter which equation? No, as long as I just wherever we started with the one of the 2 equations. Now, looking at the 2 again, which do you guys think will be the easiest, the first one or the second one to plug this into? First one. It's really straightforward, the first one. So we're going to plug that right back into the first equation. Equation 1 said x plus y was equal to 10. So in this case, we're going to replace y to number 4. Quickly, what is x going to be in this case? That's right. 4, 10. We bring 4 over. X equals 6. So, we got our values here. So, we have our values. X is 6 and y is 4. So let's go back to where the question was asking us. How much of each solution did they need? How many liters of x did we say they needed?
4.
We needed 6 liters of 30% solution, and we needed 4 liters of 60% solution to get this 10 liters of 42% sulfuric acid solution.